Hi, welcome guys. There's an interesting video code that you have been Pythagoras wrong all these years. Oh, sorry. So this video was the author claimed that there's an interesting way to do the Pythagoreans. Which he claimed that we are doing the Pythagoras wrong all these years. So let's build a video to debate this. Okay. Yeah. So the author claimed that for this one. Okay. So let's see. We have 3 examples. Okay, so you might go to check this video if you're interested, and also claim that in order to find this one, right, in the third side, then the usual idea is that you will use a 3 squared plus 4 squared, right? It's 5, right? And this one you can check that the 60 squared plus 11 squared you get 61, and this is 13 squared plus 84 squared you get 85. Okay, so the author claimed that there is another way to do this, which is just using take the shorter. So the author claimed that take the shorter length square minus the longer one. Okay, so for example, this one is 3 squared minus 4, which is 9 minus 4, 9 minus 4, which is 5. And this one can be equal to take the shorter square, so it's 11 squared minus 60, right? So it's 121 minus 60, so it's 61. Okay, and for this one, you can check that it's 13 squared minus 84, so this is 196. Also, around is 69 minus 84, so it should be 85. Okay, so it's amazing that the author claimed that this should work, right? So very amazing that the 3 of them should work. Okay, so now let's find the truth. Okay, very happily the truth. Okay, so the truth is that these 3 triangles, these three right triangle are specific, like the specific model. So the reason is that let's see. Suppose you take this to be n plus 1, this to be n, and it's easy to check that this one will be n squared minus n squared. Take a square root, right? So this guy will be square root of 2n plus 1. Okay, so this is actually the model. So this trick only works for such model. Okay, so basically, if you have a length n, the next is a square root of 2n plus 1, then you can use this to find the answer. Okay, the reason is that in this case, the shorter one must be square root of 2n plus 1, and the longer one must be n, right? So the answer will be this one, right? This n plus 1 will just be square root of 2n, the shorter square minus n. So you get 2n plus 1 minus n, which is n plus 1. Okay, so let's use this specific model to make this one, right? So let's see. Okay, so the first model is 3, 4, 5, 3, 4, right? So from this model, we know that n is 4, right? So easy to check that this will be 5. Okay, for this one, I guess 11 and 60, right? So this will be n. This is square root of 2 times 11 plus. Sorry. I'm stupid. So for a second example, 60, 11, right? So for a second example, this n is this, right? So easy to check that 11 will be square root of 2 times 60 plus 1. This will be 120. Okay, about this one, then it's easy to check n plus 1, right? So n is 60, this is 61. Okay, so this one also work. So let's see. So 13 and 84, right? So 13 and 84. Easy to check that this is n, and easy to check that this is square root of 2 times 84, which is 168 plus 1, which is 169. So it's 169 square root is 13. Okay, so this is 13, and this guy will be 85. Okay, so this is why author claim this amazing strange trick should work, because this strange trick only works for the specific models. So conclusion, only works for specific ones. Okay, so let's maybe see the counter example. Right, so seriously, we are doing math, right? People doing math, like, so let's say 6, 8, and 100, 6 and 8 and 10, right? So if you take the shorter one, which is 6 squared minus 8, you get what? You get 36 minus 8, right? So which is 28, right? Not equals to 10. Okay, so simple counter examples shows that this stupid trick should not work. Okay, I still like this guy's video, and hope you guys like those. But just to make everything to be clear.